using SOLIDWORKS 3D Interconnect. My name is Joelle Guenette. I am the Territory Manager for Eastern Canada, which is Ontario, Quebec, and the Maritimes. And with me is Michel Cloutier, who's the Territory Technical Manager. And together we will share some information with you today. So this is our first webinar of 2019, and we thank you for joining us, and we hope that this information will serve you well. Bit of logistics before I get into our topic for today. This is a go-to webinar. You will notice on the go-to webinar panel, probably on your right-hand side of the screen, that there is a handout that you can download. So please feel free to do so at any time. Just below that is a chat section where you can type message here. So if you have any questions as we go along, please don't hesitate. Type the questions there. And at the end, Michel will review them, and if there's anything that hasn't been covered during the time of the webinar, he will definitely take the time to answer them, or offline if it's something a little more in depth. All right. So our topic today is about working with other files, and why we're addressing this is because it's a main concern for our users and our potential new users. And it has been indicated that the reason why people change CAD tools, which kind of leads to one of the important things for looking or for the tool you are using, or one of the important features for people, is the ability to work with multi-CAD data. So as you see, it comes up third on the topics or on the reasons for changing or on things people look for in their CAD tools. Why is this? Well, you may be working with components or pieces or parts that you're buying that you would like to integrate into your design. You may be working with parts that are being designed by another company that's using another tool. You may have legacy files in your company that were designed some other way by some other tool than SOLIDWORKS, and you need to work with them, or by another division in your company that for some reason is not on SOLIDWORKS, and therefore you need to be able to work with their files. So there's a lot of different file formats, there's a lot of different files out there, and more companies have to interact with them and need to know how to work with them. And this is why we're going to share this information with you today. And actually, it's Michel who's going to share this information with you today. So as I said, he's a Territory Technical Manager. We've been working together for 4 years, covering the Eastern Canada area and meeting possibly many of you, or working with many of you. But Michel has been with SOLIDWORKS for 14 years, so he's seen a whole lot of changes over the years, and this is one of the great ones to help facilitate your day-to-day activity, and he's going to share with you how this can benefit you. So with that, over to you, Michel.
Well, thank you, Joelle, and thank you everyone for attending this morning's session. Like Joelle said, today we're going to tackle a specific topic, which is one of the tools inside of SOLIDWORKS 3D Interconnect. And just to give you, like, if we could sum 3D Interconnect in one phrase, what would it be? The idea with 3D Interconnect is to allow to work transparently with third-party native CAD files. Actually, I say third-party native, but also neutral files. I'll get back to that. But before I start and I show you how to actually use it, and I'll do some bit of a demonstration, I'd like to actually ask you a couple questions. So first of all, I'd like to know which version of SOLIDWORKS you're working on today. So the poll is open. You can actually select the version you're working on today. This is going to help me because some of the functionality in 3D Interconnect came in through different versions of SOLIDWORKS. So that's going to help me a little bit focus better on what to talk about. So I'll give maybe a few more seconds for people to vote, and I see the votes coming in. So thank you for your participation. Let's see the results. So on this morning's session, we see that the majority is actually using SOLIDWORKS 2018, and it just so happened I'm going to do the presentation today using SOLIDWORKS 2018, but I see people using 2017, 2019, some 16. So that's good to know. So thank you for that. I do want to ask another question before we start. And this time it's about file formats or native file formats. Which of the following file formats do you have to import or work with using SOLIDWORKS? And I believe you can actually select have multiple selections. So again, I'll let people punch in their answers, and I see the inputs coming in, so that's great. Again, thank you for participating. Let's give that a couple more seconds, and I'll share the outputs, the results. So yeah, so let's close this and share. So a lot of Autodesk Inventor data that you want to import, PTC Creo, some CATIA V5, NX, Solid Edge. Good, that's good. Today, the examples I'm going to use today are actually going to be Inventor, Creo, and Solid Edge, but I'll talk a little bit more about the other formats because they are supported. So in the meantime, let's just get back to to our topic today, which is 3D Interconnect. Now, what I want to show you guys today is different methods of using the tool. I'm going to use the first three methods of using the tool, which is as an assembly reference, as a derived part, and breaking the link. And I'll get back to that a little bit when I get there. And then I want to talk about additional capabilities that were introduced a little later. Now, for the users out there, 3D Interconnect actually came inside of SOLIDWORKS in 2017. So the first three chunks there we can actually do inside of SOLIDWORKS 2017. Additional capabilities came in 2018 and a little bit in 2019 as well. So I'll try to separate everything so that it makes sense. Now, the first example I want to use and how to use 3D Interconnect is to simply, use it as an assembly reference. So I'm designing inside of SOLIDWORKS. I got a component coming in from another system. I just want to put it together, made it in place, and go on with my job. So that's exactly what we're going to do. The example I'm going to show is this one here. So this is my SOLIDWORKS assembly. This is actually part of a device to help people with limited mobility, like partial paralysis and something like that, to help them with their movement for the arm specifically. So that's my SOLIDWORKS assembly, but my supplier is actually using Inventor to design the battery pack. So what I want to do is simply take that Inventor design, put it inside of SOLIDWORKS, and go on with the rest of my job. So let's switch into SOLIDWORKS, and we'll see how we actually go about doing that. So here I'm inside of SOLIDWORKS 2018, as I mentioned before, and that's my little assembly. And we're going to focus in where the battery needs to be positioned. So that's where the battery pack should go. Now, how to use 3D Interconnect is very simple. You actually simply insert component just like you would with any other type of files. And here I'm going to go in my supplier parts. That's my Inventor files here. I'm going to filter down to my Inventor assembly, select it, and simply say open. So the process is identical to inserting a sub-assembly inside of SOLIDWORKS. So as I put this in, you'll notice first thing, it's very quick. So we don't actually translate the files. We simply read the file inside of SOLIDWORKS. If I put some transparency a little bit on that cover, you'll see that it's a 8 battery, small AA battery pack. Now I need to position that into my assembly. So using standard, mate tools that you're used to, familiar inside of SOLIDWORKS, I'm simply going to control select the back face and this face here, make it coincident. You'll notice as well that I do have access to the planes of that subassembly, even though it's created inside of Inventor. So I'm simply going to control select the plane of the battery pack with the symmetry plane of my assembly, put that in place. If I rotate this a little bit, you'll see here there's a face that I need to make tangent to the bottom here. So very quickly, we're going to do that. And the last step I need to do here is that you'll notice this support here, this support plate right in front. Now that needs to be kind of snug with the battery pack so it doesn't float around, right? So again, I'm going to simply say select other and pick the back face, and then pick the front face of my battery pack, make it coincident. And you'll notice the rivets here. When I do the update inside of SOLIDWORKS, those rivets are designed in the context of the assembly, meaning that if I move this plate here, well, the rivets move along with it, right? So that's smart design right there. Now, I've simply inserted the battery pack, mated it into position. Now, one of the really nice things about 3D Interconnect is that, like I said, we don't actually translate anything. We simply read it in. And that means that 3D Interconnect is aware of changes on the native files. So for example, my supplier sends me the small battery pack. It's not powerful enough. I want something that lasts longer, bigger batteries. So I ask him to do a redesign and send the new versions back out to me so I can update my assembly. Now to simulate that, this is actually my folder where my inventor parts are, and you'll see here I got a zip file version 2. So what I'll do with that zip file, I'll simply extract it here and overwrite version 1. Yes to all. So I've saved those files and overwrite the version 1. Now going to SOLIDWORKS, if I do a update here, you'll notice a little symbol. It's kind of hard to see, but when we look over here, there's a little like a circular arrow, and that's actually a cue that tells me that, hey, SOLIDWORKS has detected a change on the native files. So now I can go here and simply say, hey, go ahead and update the model. So SOLIDWORKS simply reads the model again, updates it, and as you can see, everything is updated here. Even though this is a important model, and if we look at the mates, and that's what's really important here, is that you notice that all the mates are still working. They're all good. Nothing got broken. So the mate on the back face, the symmetry mate in the middle, that tangent mate, and even the front plate was updated accordingly as if it was a native SOLIDWORKS assembly, subassembly. So that's great because, when we do these changes, it's really fast because we're not actually translating the file. We're just reading the file in. It's easy, but also, as you saw, it basically reacts pretty much like a SOLIDWORKS subassembly at this point. Now, another method that we can use 3D Interconnect is to use to open up files from other systems and use them as derived parts. So here's an example. I got this little gear designed in PTC Creo, but I can't use it just like that just yet. I need to add a couple things. I need to add a keyway, and I also need to add a slot. And once I've done that, I'm going to put it inside of my assembly. So again, let's see how we could go about doing that with the help of 3D Interconnect. Now this time, instead of inserting, because I know I need to do some changes, I'm simply going to say File Open, and I'm going to go to my Creo folder. That's my part.1, and I'm going to say Open. So you can either insert or open using 3D Interconnect. It's pretty much the same thing. And as I mentioned, I need to do some changes here before I do anything else or put it inside my assembly. Now, to save me some time, I actually have some library features. So here's my keyway. So I can simply drop it over here. It's asking me for an edge to constrain it. So I'm gonna simply pick an edge here. So that's going to work really well. The other thing I want to do as well is to take that curved slot, put it over here, just like before, asking me for a reference. I'm gonna select the curved edge here, click OK. So as you can see, and let me save that. Actually, I'll save it and I'll override the existing one. You'll notice in the design tree, my base part is over here, and then I got my SOLIDWORKS features that was added to it. Now I need to insert that inside my subassembly. So I'll simply move that window to the side here. And whoops, sorry about that, mispicked. Let me just get back. And let's say we're going to make that window a little smaller. Now the gear needs to go right over here. Now a little trick here, for the SOLIDWORKS users out there, when you want to insert parts into an assembly, picking an edge will actually launch the mate command as well. So just by drag and drop using the edge, I'm going to add a concentric and coincident mate all at once. So saves me from doing a bit of extra work. So as I position the gear over here, I notice that the slot, isn't really positioned right. So I need to do some changes to that. I'll need to do some edits. But like I was saying before, this was done in Creo. So again, I would go back to Creo and change it. But in Creo, for people who are not familiar, Creo actually creates version files. So the .1, .2, .3, that's their way of versioning files. The beauty is that SOLIDWORKS understands that as well. And you may have noticed this when I initially inserted it inside my Creo folder. I actually had the .1, .2, and when SOLIDWORKS will see a new dot file, if you want, you'll be able to update it as well. So if I go back over here, I go on my base part, and I say I want to update model. I'll click Update Model. You'll see the new gear design with some holes added to make it lighter. But also notice that my keyway is still there, right? It's still okay, nothing broke. Same thing with the curve. So everything is still there, still working fine. So going back to my subassembly, it's just a matter of updating my subassembly, and here we go. We got the files updated, right, ready to go inside my subassembly. So again, a really great way to use this time as a derived components is that there's no errors during changes, and that's really a good thing. You don't want to do extra work when you work with some updated files. Now, the last example I'm going to show using 3D Interconnect is to actually break link. And when we do a break link, we're basically doing a traditional import at that time, creating a SOLIDWORKS file. But we can leverage some technologies inside of SOLIDWORKS to recognize features and save ourselves some time from remodeling. So here's the example. This time I'm going to use a solid edge subassembly, small subassembly consisting of 3 parts. Now the motor and the pulley I want to keep as is, but the mounting plate I might need to redesign that. I'm guessing that some of the holes might not actually fit, so I want to do some work with that. So let's go ahead and see how we would tackle again a design like this. So back inside of SOLIDWORKS, I'm going to simply insert my solid edge assembly. So again, I'm going to drill down to my files and select a solid edge assembly. There we go, and click open. This opens really quick inside of SOLIDWORKS. As you can see, I didn't translate just yet. It's actually just opening inside of SOLIDWORKS. I pick an edge, Alt drag to invoke the SmartMate command. Again, another tip there if you're not using that, that's really helpful. Control select and make it concentric. Now, as I start looking around, the screw hole seems to be fine, but you see here, those 2 holes here not aligned really well. So I'll need to do a change to the base plate so that fits really nicely. Now, before doing that, what we'll do is simply take that subassembly and say I want to break link. When we do a break link, basically what this does is that it only now does it actually creates a SOLIDWORKS file. So now I got my SOLIDWORKS assembly that's right over here. Now the motor and the pulley, I don't need to change that, but the plate, the mounting plate, I'm going to break the link of that as well so I can do some edits to it. So going into the base plate, one last time to break the reference, And now you'll notice in the tree, for the users, familiar with importing files, at that point, it's more or less a traditional imported file. But with that imported file, you could actually leverage some of the capabilities built inside the SOLIDWORKS standard, namely FeatureWorks, to actually refeature the whole part or only what's needed here. So for example, I refeatured or reverse engineer the whole, and now this is actually a native SOLIDWORKS feature. So I can change the type, change the size. Really, I did that at this stage to change the position. So if I want to reposition correctly in my subassembly, I could go back to my subassembly over here. I'm going to say I want to edit this part. And when I select this feature here, I'm going to go ahead and edit the sketch that has that center point, and that center point actually depicts the center of my hole. So if I change that to a silhouette edge display, I can pick through the model, pick the center point, make it concentric to the part next door. And there we go. So very quickly, I was able to reposition this hole and redesign that base plate with minimal effort. What's kind of neat though is that even though the base plate is now its own SOLIDWORKS document, both the drive and the pulley are still linked to the native solid edge file. That means that if I change the pulley or the motor in solid edge, I could update it downstream as well. So very quickly, we kind of saw three different ways of using 3D Interconnect. Using the break link allows us to simply create an actual SOLIDWORKS file coming from the other format. Now, the last thing I want to talk about is additional capabilities. So like I mentioned before, we have a mix of users using 2017, 18, 19. So what I've shown so far, you can all do that starting SOLIDWORKS 2017. But we added some capabilities in 2018 and a little bit in 2019 as well. So I want to cover a little bit more about that. So in 2018, we added the ability to not only open third-party files like Inventor and Creo, but also neutral files, the step, the IGES, and we also support more information inside the file. So we'll be able to read in reference planes and reference axes, sketches, but also properties, material description, and I'll show a little bit of that. Now, before I show that, I want a last poll. I want to ask you guys, if you do need to open neutral 3D files, what would it be? Again, you can vote for all that applies. If you don't use any of them, also the last one is others. Sorry, that's I spelled in French. So the last one is other. So I'll let you guys vote a little bit, give you a couple more seconds. So thank you very much. I see the participation, which is really nice. So let's go ahead and close this and again share it. So a lot of you guys, well, all of you guys, have to deal with STEP, and that's very common. IGES, ACES, SAT, a little bit of GT. All right, so that's good. So part of the additional capabilities that we added in 2018 is exactly that, the ability to read using 3D Interconnect to read the STEP, IGES, and other file format. Now the benefit there is speed, especially with large imported designs. So let's take a peek of some of the capabilities here. So this is a design, another design. This time I'm going to insert a step file. So using the exact same method, using the file format, I can filter out my step, select the step file. It imports pretty much the same way that you saw me do the other file formats. Here's a nice little tip as well. If you want to center this, select the loop and then the back face and use a profile center. So a really quick way of positioning a dial like this. Now, I also mentioned about other design entities inside the file. One of them is sketches and planes. We often have reference planes to help positioning or sketches that we might want to repurpose in a new design. So, and that's exactly the case where we have that little dial. If we look at the plane, you'll see that the plane 1 here, that's actually a reference plane from that imported files that we can repurpose. But that imported files also has sketches that I want to repurpose. So I want to repurpose that sketch to simply punch a hole so it can actually fit in my my design. And that's really how all there is to it. I could have, convert entities, but here I had access to the sketches, so I use the sketches. And another way that we can leverage even further is that now in 2018, when we open files coming from other system, we also read in the properties, description, material, part number, all of that. And that means that when I'm ready to create a bill of material, I don't have to type in any of that. I get all the information populated into my design. Here in that bill of material, the last 5 items are coming from other systems. I do have the part number, I do have the description, I have everything ready for me to use. So in 2018, we added some more capabilities so we can leverage that information even further than what we could before. So that's really useful. So if we wrap things up a little quick, so we saw how we can simply use 3D Interconnect to insert components, put it in position, and be done with it. So that's my assembly reference. It's fast, it's easy. We can also use 3D Interconnect as a base part or derived part, and then add some features to it. But mind you that if there's a change, nothing quote unquote blows up. You still have, everything works together still. And then the third method is that you can start using 3D Interconnect and then break the link to create a traditional type import, then use maybe FeatureWorks to refeature it, or direct editing methods to move a hole or delete a hole or things like that. So it's very, very, very flexible. And then some additional capabilities we added in 2018, namely the support for native neutral file formats. The properties, for me, that's a big one. I hate typing, so if I can grab description and material and part number back from original file, that's a time saver for sure for me. But also reference planes and axes, sketches, and things like that. So that kind of wraps up, what I wanted to talk about today. Maybe a last slide just to talk about the different file formats supported. You're probably going to ask the questions anyhow. Obviously, you saw me use Inventor files, so we do support that. You saw me use some Creo files. You saw me use some Solid Edge files. We also support UGNX. And we also support CATIA V5. Now, for CATIA V5, you need SOLIDWORKS Premium. But for anything else, that's part of core SOLIDWORKS starting in 2017, additional to ACES, STEP, JT, and STEP files. So all of those formats are supported through 3D Interconnect. We do support additional format in the traditional sense of importing files, but really 3D Interconnect it's all about speed and making it faster to come inside of SOLIDWORKS and use it. I'll just leave a couple of quotes on the screen just so you can read them through. Some users testing it were really mind blown by the capabilities. It's really about saving time and making the process much easier and faster. So I think I'll leave it to Joelle to do the final words. While she does that, I'll take a quick peek at questions. Joelle?
All right, thanks, Michel. Great information. You guys got a 2-for-1 today, so you got some information on 3D Interconnect and how to work with all those lovely other CAD files that you may have to interface with. But I noticed you also got some tips and tricks on working with SOLIDWORKS, so that's a great little bonus. for you guys today. Were there any questions, Michelle?
Yep.
In the
So,
yes? Oh, there you go.
two quick questions about the new capabilities in 2019 for 3D Interconnect. There is in 2019 we can read tessellated data from imported files. So Christopher asked that. He also asked about JT. So yes, JT files are supported in 2018. I think that it actually came in Service Pack 2 or 3. So I can double check, but they are supported in 2018 Service Pack 5, that's for sure, because I have Service Pack 5 installed and I see it in my list. As far as AutoCAD, it's not supported through 3D Interconnect. It's really just 3D data at this stage. But that's all the questions. So good question. So thank you for asking.
All right, wonderful. So once again, thank you for being on today. If for some reason you'd like to see this information again because you forgot part of it, it is recorded. If you want to share it with somebody else, feel free to do that as well, either through the link that you received for joining the call, the link you received for registering for the call, or this lovely link here. So multiple ways for accessing this call, as well as recordings that we've done for previous webinars in the past year or more, actually, that are on this site. So feel free to access and see those as you want. If you, for some reason, run into some issues, it doesn't quite work like you remembered, or you're not quite remembering what to do, of course, there's information probably on my SOLIDWORKS.com, but there's also your resellers. And you can also contact us if there's something else that we can do for you. We'd be happy to help. Our emails are listed here, and again, your resellers are really there for assisting you in a more direct way with these types of things. But if there's other questions, don't hesitate and contact us directly. Or if you don't remember who your reseller is, I can also assist with that. With that, we're going to give you back some time that we had reserved in your calendar, and wish you a great weekend, and hope we see you on future webinars or live events that we schedule. Thanks, everyone. Thanks, Michelle, and have a great day.
Thank you, everyone.